Okay, this is 12.3 notes. We're going to rewrite and evaluate logarithms. This is like log basics. So this is where logarithms came from in the first place. I need you to know a couple things. For one, logarithms, they're just exponents. It's just another way to write them. So a logarithm is an exponent. Now, where did it come from? Let's look at something very basic. Nobody has a problem with 2 to the second being 4 or 2 to the third being 8. But what if I asked you what the exponent had to be in order to give you 6? So most people would think, well, 4 and 8, halfway between them would be the 6. So halfway between 2 and 3 would be 2.5. But as you can see here, 2 to the 2.5 power is not straight up 6. I want to know what 6 is. So if this is not the case, where'd it go? There we go. Then we have to figure out what actually is the exponent. So a long time ago, it was decided that a way to rewrite it, to figure out what that exponent is, what that missing exponent is, you write it as a logarithm. Now, this is saying, and this is where it's going to get weird, okay? So you have a base to an unknown exponent, and that equals an answer. To rewrite that as a logarithm, to find that missing exponent, you have your exponent so your exponent, we say, is log base b of answer A. So this is where it's going to get weird and probably a little silly, but it's memorable and it's to help you. So you've got two forms happening. Exponential form. For exponential form, we're going to be a. We have a base to an exponent, and that equals an answer. To convert to logarithmic form, because a logarithm is just an exponent, it's just a different way of writing it. This is where it's going to get silly, and you're going to laugh. We're going to be a bay. We're going to be a bay. Exponential form and logarithmic form. So see, if log is bay, you have log of the base, whatever that number is, so log base b of the answer equals the exponent. Log is bay. Exponential is bia. We're going to be a bay. Now, converting from logarithmic to exponential is really easy. I call it the loop swoop. So you have a base to an exponent, and that equals an answer. You begin at the base, you loop it, and swoop it back around, the loop swoop. So exponential form is bia. Logarithmic form, log is bay. We're going to be a bay. So back to this example. How do I type this in? Easily. And this is why your calculator is so handy dandy. So if you'll notice, you have a log button over here. Now this is for base 10. So if you were to do control 10, in an 84, that probably would not pop up. You have to do on an 84 math alpha math. Math alpha math, that's correct because it's been a long time since I've done that, should give you this formula if you have a newer 84. So here, if you do control 10 to the x and you see the log, then you can type in your base. So our base was 2 in that initial problem. Our answer was 6.
So what is the exponent? What is the logarithm when the base is 2 but the answer is 6? Apparently it's 2.58496. So what I'm telling you is 2 to the 2.58496 equals straight up 6. Now, you don't see straight up 6 because that, of course, is a decimal. So I wonder if we did it this way instead. I'm going to up arrow because we rounded. So let's go back to that. And let me see if I could do this instead. If I can do 2 to the control negative is taking that answer and all of its decimals, boom, straight up 6. Because really, we only saw this snippet of it. Look how that exponent really looks. There you go. Okay, moving forward. So our answer, our logarithm, our exponent was 2. I already forgot it. Awesome. 58496. So 585. That's plenty. Okay. All right, so then how do we do this? So let's practice going back and forth from exponential and logarithmic to exponential. So we're going to do the loop swoop. We're going to be a bay. Remember, log is bay. Base of an answer equals an exponent. Exponential is BIA. A base to an exponent, which is natural, and we already know that, equals an answer. So if I ask you to evaluate log base 2 of 8, the answer is 3. Well, excuse me, the exponent is 3. Why? Because this is saying 2 to the what power gives you 8? Well, 2 to the third gives you 8. So the logarithm evaluated is 3. What about the next example? Log base 1/4 of 4 is how we say that, equals what? Well, 1/4 to the what equals 4. It's the loop swoop. We go from bay to BIA. A base to an exponent equals an answer. So what would the 1/4 need to be raised to in order to send it across the line and change its sign? -1. 1/4 to the -1 becomes 4.